to this now. The world has been grappling with the COVID-19 pandemic for almost 2 years now, but the reality is that there is still a lot to learn about the virus. Well, Professor Resia Pretorius, the head of Department for Physiological Sciences at Stellenbosch University, is looking into the link between blood clots and patients suffering from long COVID. She joins us now to discuss this further. Prof, thank you for your time. So as you and I talk, in the next few minutes, I'll ask the team to pull up a picture that you've produced, but let's hold off on it for a moment. Let's start with what you've discovered. What is the link between what you're calling microscopic blood clots and long COVID?
Good afternoon to Lasizwe. So yes, we have discovered that in long COVID patients that suffer from persistent lingering symptoms that do not go away with time, there are a selection of patients that have microclots and platelet hyperactivation in their circulation. And these microclots, we believe, are one of the main culprits for all the lingering symptoms that we do note in long COVID patients.
Given what we know about the clotting of blood, which is something that is essential, an essential function of the body, I don't know the exact scientific terms. Given what we know, though, to what extent do we believe that the anomaly that you've picked up leads to symptoms, and what specific symptoms is it associated with that then come to be described as long COVID?
Perhaps I must just start to note that if you are individuals that are suffering from acute COVID, while you are still infective, you also have the propensity to form blood clots more so than a healthy individual. And many of these blood clots then will go and sit in the lungs. And then obviously these individuals then have lots of health issues and actually can also die from blood clots in the lung. So in a population then of long COVID individuals, these microclots do not break down. And as you rightly noted, in a healthy individual, there is a process where microclots form, but not to the extent that we see in long COVID patients or acute COVID. And then your body has a methodology or a physiological process where it then can break down the clots again. So to our surprise, we found that in long COVID patients, these microclots that form are a really long time in the circulation of these individuals. They persist, therefore, in circulation, and they do not break down with the usual, we call it fibrinolytic or breaking down of clots that in a healthy individual you would find. Now, the reason for this is we found that trapped inside these microclots are a lot of different inflammatory molecules and also a novel molecule that we discovered that is called alpha-2 antiplasmin. And that molecule is actually the main culprit, we believe, that prevents the clots when it's formed in long COVID to actually break it up. And about the question, what symptoms can it cause in a person suffering from long COVID? Typically, long COVID individuals suffer from conditions like shortness of breath, sudden pains in their lungs. They might also have all sorts of other complaints where they say they have got brain fog or they struggle with concentration, and all other organ systems might also be affected. And we believe that all of these symptoms that they have discovered or mentioned in long COVID, we might track down back to microclots in circulation.
I like that. I think that sums it up really nicely. In fact, at this point, I think, Prof, it's the best point for us to bring up that picture, because I thought it was quite dramatic, the picture you shared of what healthy blood plasma looks like, and I presume this is under a microscope, and what microclots in plasma from an individual with long COVID look like. As we have the picture on the screen, tell us what we are looking at. You may not be able to see it on your side, but it is your picture. What's the difference between the two? Healthy blood plasma, microclots in plasma from an individual with long COVID.
If you look at the micrograph, that is a photograph taken under a specialized microscope we call a fluorescence microscope, that lights up the aberrant or anomalous clots that is in circulation. In a healthy individual, you will see little green dots. Now, these little green dots you will find in any healthy individual. It is just here and there anomalous clots that might form due to the normal aging process or inflammatory status of an individual, even if you are very healthy. However, in a long COVID individual, we found these massive clots, and you can see the difference in size. And if you note the scale bar there at the bottom, that scale bar can give you an indication how the size difference between the clots inside a healthy individual and those that are found in individuals with long COVID. So those clots can actually, be so detrimental to the health, to your lungs, if one of those clots can go and attach to the lung capillaries or the blood vessels. So the difference is the microclots are really persistent. They do not seem to go away, and the molecule of interest is the one that I mentioned earlier, alpha-2 antiplasmin, that prevents these microclots from breaking down.
Lastly, Prof, the so what of it all. Now we've been able to characterize and say that these microclots in the plasma, in the blood plasma, and the failure to break down clots in people suffering from long COVID is linked to the symptoms. Now what?
The next is treatment. We need to identify molecules and methodologies to address this clotting and the microclots that are persistent. So we are working, our research team are working with clinicians from South Africa, but also clinicians as well as researchers from all over the world, including Germany and the USA and other parts of the world, where we investigate possible methodologies to tackle these microclots. So the important thing is that we are onto it, we're looking into it, and we believe that a treatment option is around the corner.
All right. Prof, I know I said it's the last one, but I'd be irresponsible to not raise this, and I almost made the mistake of not raising it. The concerns that people have around clots that are linked to side effects and adverse events from vaccines versus these clots that you are talking about. Just clarify what the difference is here. Is one more at risk of these clots forming and causing these complications from vaccine adverse events, or is it the other way around, that actually the risk of these clots is higher from long COVID, for example?
So this is a very important question that we need to answer desperately. We as researchers at University of Stellenbosch, we believe that vaccination is the only way how we are going to succeed to not have a fourth wave. So this is the first important thing to note. However, there are reports of people that have adverse effects and have struggles with microclot formation after the vaccination. This needs to be looked into, and then this needs to be a research question to be addressed. If we know what we are looking for, we can prevent it, and we can have suggestions of treatment options. So definitely this is an important research question, and not only us, but also other researchers over the world are looking into reasons for that certain individuals might develop microclots in circulation.
All right, Prof, thank you so much for your time and your insights. That's Professor Resia Pretorius from she's the HOD of Physiological Sciences at the University of Stellenbosch there, helping us make sense of some, pretty complex science, but important science nonetheless around the issues of long COVID.